So my name's Kapadia. I'm the security architect for one of the IBM products called API Connect, which is Chris is going to introduce what the product is. I have been in IBM for over a quarter of a century, so I'm old. And I spent a long time working in consulting, going out to customer sites, dealing with real world problems. And then I moved into development when I decided I don't want to get phone calls on Sunday saying, can you be in Johannesburg on Monday anymore? And since then, I've been in development organizations, moving around, always in a security focused role. So that's me.
Thank you. Firstly, IBM API Connect. We've mentioned this briefly a couple of times. This is IBM's API offering. It provides a platform where you can build, manage, socialize, and secure your APIs. Helps I have a clicker in my hand. And the idea is this is a single place where you can come, take APIs being built by multiple teams, build them in a consistent way, socialize them in a consistent way, socialize them for your target audiences so they can consume more easily. Try now. If you'd like to know more about IBM's API Connect, please come reach out to me, drop us an email. We're not salesmen. We are product development, product support. We use it. We help customers use it. Okay. Apologies for the technical challenges. So let's set the scene here. Everyone has some sort of enterprise application. Now, when I say enterprise, everyone has built some code that runs on a service, cloud, that has a job. And more, as I said, we are seeing it. You need to connect to external, either SaaS solutions or external services. Fairly standard approach. Does everyone following this? Everyone's got an application that connects to something outside of their business, right? One person, a couple of nods. So the problem is, the reality is there's now so many SaaS services out there. You've got to contain all of these connections. And what's worse is, let's be honest, you don't have one application, do you? You have many, possibly hundreds of applications in some of our clients, connecting to tens, 20s, hundreds of different SaaS systems. Now, that could be an AI solution. That could be a CRM. Could be something that I've never heard of before. But the fact is, these applications have to build the connectivity and the contract around the interface between their applications and their target. And what's more is we're now even seeing worlds, and this is very common these days, where the SaaS systems talk to each other. So you could have a CRM system out there that when you get a new record, you have a macro inside of it or something that will then go and create records at other CRM systems. So what we are here to talk about is the idea of taking this challenging governing, I use the word governing carefully here, challenged and hard to understand, and put in an API or an integration platform layer in the middle of it. So here we have all the different SaaS systems. And here we have all the applications. And then these applications could connect to the different SaaS or external systems through a series of APIs that are owned by the API platform. And the key thing here is the API platform is owned by the same organization that owns the enterprise applications. So this API platform could be a product that is then resold, reused, shared, however the words we want to use it, inside the business. So we're going to go through the four, and Salesforce come and use the same APIs. So the four areas in this we're going to cover quickly today is why this is good for control and security, accountability, protection, and simplified migration. So Simon, over to you.
Thank you, Chris.
Of course.
So I'm not going to walk around like Chris does because I'm mobilically challenged, as you can see. I'm just going to sit here at the back and hopefully move things in the right direction. And we're having technical difficulties with the clicker. There we go. Whenever Chris wants to talk to someone about security, he pulls me in to discuss things because that's my excuse for going out and talking to customers about SRE, which is I like getting out into the real world every now and again, working in a development organization. That's hard. But there are some real security challenges with deploying something like this. So there are enterprise applications at the moment. Let's take a scenario where two enterprise applications are talking to some SaaS provider. So these things are in your business over here. This thing is some third party out there over the internet. And in order to contact that provider, how you authenticate to it is you provide a key, and you've agreed an API key that they've issued to you as a company, And then both of your applications, enterprise applications individually, have to connect over to that SaaS server and pass the API key in as they go in. That's our basic scenario. That's the wrong button. So that's our basic scenario. Now, if that API key is compromised, what happens? Yeah. So let's say that the developers of Enterprise Application 2 over here, they're going through and their normal CI/CD pipeline, and someone takes that API key and they include it in a Git commit that's making a change to that enterprise application's runtime deployment. Now, of course, they immediately notice that they've done this, and what they do is they delete the commit and forget about it. But the moment they've done that, the secret that they've uploaded there is compromised. Someone who knows how the source code management system works can go through and look at the history and pull that information out of there and steal it and use those credentials themselves. So the moment it's become public in that kind of manner, it's compromised. So what happens is that you have to reset this API key. And the moment you do, it's not just Enterprise Application 2 and the developers who screwed up there, or the GitOps people who screwed up there, who are affected. It's both applications, because you've only got the one key shared between them. Both of those applications are now going to have to update and distribute that. So you have the further problem of key management, of distribution of this API key between those applications. And even though it's only one of them that made a mistake, both of them are impacted. Now, of course, it's never as simple as two applications and one thing on the outside. As Chris showed, there could be multitudes of applications out here that are using these services, and there could be multiple different services outside. And things get complicated very quickly. These applications are probably different technologies. They may not all have the same capabilities. Some of them might be capable of using a simple API key or whatever is required for these systems out there. Some of them might be, I don't know, say it's a Java enterprise application, which is only capable of authenticating by presenting an X509 digital certificate, and it has to use MTLS in order to authenticate. This thing down here, the only way it can actually make outbound calls is by using OAuth through a third-party identity provider. And all of these need to be able to talk to these bits of data, to these services outside. What we do is we build a relationship here where the API platform controls the inbound connections where it's representing these external services. So Enterprise Application 1 uses its credentials to authenticate to the API platform. And the API platform then knows how to pass those requests on to the appropriate service at the back end. Now, all of these applications have their own credentials as appropriate to the technology they use, as I said. But on this side, out in the internet, the different web services that are being called also have their own different mechanisms. And one of the key things that the API platform here is doing is mediating the tokens between them. It understands and can speak the language on this side, and it can decide what's appropriate to be able to make those calls to the back end on the other side. Let's simplify this a bit. Now, what happens if this key here is compromised? So this is the key that Enterprise Application 2, remember, these are the guys whose GitOps developers took their API key that they have and they stuck it into a Git commit by mistake and then quickly reversed it. If this API key is compromised, Enterprise Application 2 has trouble. We have to revoke that key and everything has to stop working. But because the relationship is now between Enterprise Application 2 and the API platform, which we control, the only impacted application is this one. So Enterprise Application 1 is still perfectly capable of going through to the API platform and off to the outside system. Now, what happens if API key ABCD1234 on the right-hand side here is compromised? Well, in this use case, we reset this API key, but we only have to reset it in one place. We don't have to distribute it to all of the enterprise applications that need to call that external system. Yeah. So the advantage of that should be pretty clear. You only have to update here, and it only affects that relationship. So I'll pass it back over to Chris to talk a little bit more about accountability.
Thank you, Simon. So security-wise, security and accountability go hand in hand. The key thing here is when you have multiple enterprise applications calling multiple APIs, how do you know who is using what? One of the conversations I generally have with customers is how do we cross-bill, or how do we work out which team is using the most capacity? How do we understand if we see changes in capacity that we're not expecting? So an API platform's already got that built in. It's got the analytics capability, nearly all of them have built in, to understand and track the API usage. So we're just using that for the way it's intended. By all this, each request that goes into the API will have some identifier, normally a client ID. This will map onto the enterprise application itself. And then inside of the analytics, we can then track who's using what. So we can see, we can have a single contract between the API platform and all the services down here. So you can have an economy of scale. You have each client has their own calls directly. Sorry, 1 second, my throat. Each client has their own calls directly calculated. So the platform knows who is using what and can ensure that they're billing internally if that's desired, or at least protecting and making sure people aren't using too much. And finally, we can detect unusual call patterns. Is this system suddenly calling this generic SaaS service, which we never expected? Is there a malicious actor taking place? Because as designers, no one's told us. You can catch these things earlier and quicker. And if you take the pattern where we have a SaaS to a SaaS communication here, now we can work out, is the data throughput going through as we expected? Are we expecting more requests? Also, are we seeing unusual call patterns? And we don't need to put the credentials directly into our SaaS platform for the other SaaS platform. We can have it so it has to go through our systems. So if they are leaked by accident, by human mistake or whatever, this can more easily be caught. So I've got a quick video to show on this, an example of using IBM API Connect with our AI gateway capability. Now, our AI gateway capability allows you to connect to a number of AI providers, and it can give you accountability and tracking. So this is, in the interest of time, I'm going to be playing this and going through quite quickly. So here we have our application. This is our enterprise application. We're going to grab the credentials out of here. We're going to chuck them into our testing tool. And our testing tool is going to call an API. This API is running on our API Connect SaaS platform. And it's going to call the Watson X, IBM's AI platform. And it's going to send in this request, use this many tokens. All good so far? Cool. So here we can come through, and here we can see, here's the response. And we can see in the bottom left corner, this response took about a second to come through. Or 2.5 seconds to come through, sorry. And here we can see the response in the JSON payload. So this is a machine-to-machine call that we're simulating with the testing tool. We're then going to run this again, and I'm going to be in the way for this point. But now, because we can use this, we can cache the request. So we're reducing the number of calls on the downstream system, and this took 324 milliseconds, so you can see the request has been cached. Now, before I pull my laptop off, we can now take this information, and we can go and look at the analytics side of the product. From here, we can go to our dashboards. Now, for non-AI usage, we've got 1,000 out-of-the-box dashboards. This is the same as any other APIs. The idea is you can see who is calling what and track it and understand what it's being used. For our AI dashboard, we actually track tokens. So if we scroll down here, we can see 4 consumer organizations, 4 departments or teams who are using this. We can see on the side over here that the tokens, they've used 6,000 tokens here in total across the whole system at these points in time. We can see a heat map, so you can show what point of time of day, and this can help you diagnose and predict where unusual usage is. And if you scroll down to the next bit, come on, one more graph. I'm speaking quicker than normal because I've got a clock in front of me. And if we go up, detailed usage, here we can see, you can't see very clearly on the screen, but these are the different teams that are using it. And so this team has used this many tokens, this team has used that many tokens, and so on as you go through. So from the dashboard, you're automatically capturing who is using what and the accountability and understanding this, either from a token level for AI solutions or from an individual SaaS or a request call, should I say, for everything else. And we have pie charts. Everyone likes pie charts, right? So I'm very cynical about pie chart. Then I head to Simon now for the next bit.
So you've walked off with the clicker, by the way. That's okay. I can't remember which one it is. Let's say we've got a situation where we have an enterprise application that is providing a service to end users, because these applications here at the front, they're actually doing stuff. So this enterprise application that's in your enterprise here probably has clients out there on the internet that are doing it, and you're providing a service to them. I don't know, maybe this is some kind of information system update that you're giving, weather information or whatever. That enterprise application is giving a free connection, access, and it's calling a free service tier on some generic SaaS service. Okay? And that generic SaaS service says, okay, I'm on a free tier and I have a maximum budget of $200 worth of API calls per day, because this tends to be how APIs are built in the real world. So that's our scenario here. We've got a second enterprise application here, which is also calling the same generic SaaS service, and both of these are going through the API platform. Now, what happens if this enterprise application goes viral? If your enterprise app, and this is why you're providing services out on the internet, aren't you? You're trying to catch people, you're trying to get customers to use your services. So let's say that this thing is providing weather data and suddenly it's the only weather source which is pulling information about an upcoming weather event. Let's say there's a storm coming and all the other systems somehow miss that storm. This thing gets it right and it becomes really wildly popular. What happens? Instantly, this, instead of having $200 worth of calls a day going out here, might suddenly get through to that budget of, say, 200,000 API calls in the space of, I don't know, an hour, half an hour, because that's how fast these things change. So the enterprise application goes viral and it starts exceeding the number of calls it's allowed to use. What happens there is that the bill suddenly increases quite dramatically. What do you want to do in that kind of situation? First of all, it would be nice to know that it's happening. Yeah. So you'd like to get some kind of an alerting saying this thing usually makes not more than 200,000 calls a day. And suddenly it's used 60% or 90% of that budget in the space of an hour. So we want to do something so that people know that it's happening. And secondly, we'd like to usually stop it from going over its limit, so that we don't suddenly get unexpected bills unless a human has decided that's appropriate. Because this thing where you're going viral might not actually be you going viral. It might be one of your competitors has launched a distributed denial of service attack and they're trying to use up all of your tokens on the back-end system and cause you to have bills. So that's what we mean by protection in this instance, the ability to raise an alert at some kind of predetermined threshold so that a human being or a business process can make a business decision to spend the extra money here and to protect this from doing that unexpectedly. Okay? So pass it back over to you, Chris.
Thank you, Simon. So for the last 2 minutes, simplify migration. So we've got engineers in the room, right? How many times have you implemented an external system and then for whatever reason, technical, political, financial, you've had to switch external system that does the same job? Happened to anyone in here? 1, 2, yep. It's always fun rebuilding the same code, especially if you don't actually have any engineers who own the application left. So some of the stuff I deal with is old. So one of the things, and I haven't seen this happen yet, and I'll be honest, this is my point of view, is one of the ways you could do this is you could handle or try to handle that interface change inside an internal API. If you know you have 1,000 or 500 or 50 applications using the same generic SaaS, then you can know that it's going to impact all 50 of those applications, probably in the same way. Not always, definitely, but probably. But if you could then do a hybrid interface conversion point inside the API, allowing you to map the interface from the V1 to V2, This means those applications don't need to change. This is a value that your platform team is providing with this API platform. This means simplifies the moving of external systems. Now, of course, if you want to still use the new facilities of the new system, yes, you'll have to expose the version 2 as well. But once you've moved across, you can make it with for near minimal work for the enterprise application. Take all the heavy lifting and solve it once, not 50 times for each application. But also you could do this between SaaS providers. And then most importantly, and for me, as my point of view, you can decommission the old one. How many people have systems that have been running for 10 years because no one knows if they're using them? They're being used. How many people have 20 versions of the same API live because you're not certain what's happening? I'm a big fan of decommissioning. Careful, controlled, structured decommissioning, not just turn it off and see what happens. Not a fan of the screen test. But this gives you that control and understanding because you know who's using it, you're controlling the access to it. So that's what we came here to talk about today. Very quick, I appreciate. Why we're using platforms why we're using a platform to do this. Simplify control and security. Having one point of place to track, control, and secure your external services. Accountability. Understand who is using what. If you don't know who is using what, how do you control, track, and govern it? Protection. How do you stop things, especially in a world where you're paid by consumption rate? How do you catch that so when this gets unexpected calls? And finally, migration, allowing you to switch between different services as seamlessly as possible. So thank you, everyone. Any questions? We've got 5 minutes.
Thank you. I guess you probably aware about this project's AI Gateway.
Yep.
Because Bloomberg, Solo.io, and whatever, they already implemented all the things, but based on the VoIP proxy and whatever. So on the network, starting from the network layer, maybe you are considering to, I don't know, integrate, or what is your point and what are your thoughts about these projects? Because of it can be like a standard soon.
I can't comment on our product or where our product's going or what we're doing. So what I'm going to say is, how does this map into that? There's still a lot of use cases out there where this can be fit in beyond. Now, I'm aware of what Solo.io are doing. I wasn't aware of Bloomberg's integration, but I don't have enough information to turn around and respond exactly what you're asking. I don't want to set the expectation. But there are a number of AI gateway solutions out there, even our own. The point is, we still need to track the data going through it. We still need to understand who's calling it. Now, I don't know how that solution works. Can't comment on that. I know this is how our solution works for this use case. And this is how, using our software, you can track this. And this can be applied to a wider audience. So I appreciate I haven't really answered your question here, but I don't want to give wrong information as I don't have the background, enough depth to answer it. So apologies for that.
That's fine. Yeah, that's fine. But the thing is that projects already in the community and they open source it, and all of us involved on this. So that's why